Alright, in this video we're going to talk about another way to solve systems. There are actually 3 ways. We're not going to talk about the third way, really for sake of time, and it's not something you need for this year, or usually we would talk about it. But that's elimination. We are not going to talk about elimination, so if you learn that or see those examples on Khan Academy or YouTube or anything else that you may look at, it'll be different than this substitution method. So first, let's talk about the definition of what substitution method is and the steps to do this. So substitution method is a method of solving systems of equations by substituting equations within one another. So think about this as evaluating, but we're evaluating entire equations instead of just numbers like we were before. How we do this is as follows. First, we look and see, do we have an equation where x or y is by itself? If we do, then we can skip step 1 and go on to step 2, which is substitute the expression into the other equation and solve. So let's say we had a y equals some equation, and then we had another equation in slope-intercept form or standard form. It doesn't matter. We can replace the equation that y equals into the other equation. You'll see here what I'm talking about in a second. However, if that is not the case, let's say you have 2 equations that are both in standard form, we need to solve one of those equations so that we get x or y by itself. It does not matter which one you solve for first. You will eventually need to solve for both. So choosing one over the other is not taking away from the other, I guess. Step 3 is after we solve whatever the first equation was and we get an answer for one of the variables. Let's say we got y by itself, we substituted, we solved, we got y equals 3. Now we know that part. Now we're going to take that number and evaluate or substitute that number into the equation for x so that we can find what is the value of x. Our end goal is to get a value, or get an ordered pair for your solution to see where would these intersect if we weren't just graphing it. Now, that was a bunch of words, so let's put this into action by doing some of these problems. Let's go blue. Right? So step 1, see, do we have an equation that is a y equals or an x equals? Yes. In this case, we actually have 2. So that means we're really going to substitute them into each other, but you'll see here what I mean by that in a second. Because these are both y equals, that means if this was like y1 and this was like y2, I could interchange these because they're both y. It wouldn't matter. Because I can interchange them, I can really say that they're equal to each other because they're both y. Because they're equal to each other, I can rewrite this as 4x minus 1 equals 2x minus 5. This should look familiar from when we were solving equations that had variables on both sides. So at this point, couple reminders from when we did that. I can look at my coefficients and say that this is going to have one solution because they're different. So I need to solve this and see what that is. I can move whatever I want at this point. Doesn't matter if you choose something different than what I'm choosing right now. I'm going to go ahead and move my 2x to the other side. Remember that whatever you do to one side, you have to do to the other. And then remember that with these, your end goal is get all of the variables on one side and all of your constants on the other. So now I can add this 1 to the other side and divide. So this has given me the x part of my ordered pair of my solution. I still need to find what is my y value of that ordered pair. So what I can do now is a couple different things. I can either put this -2 back in and solve and see what I get. Sorry, these are both the same, so I wouldn't want to do that here. I want to do that for another equation. So I wouldn't put it in there, but I could put it in either one of these. So kind of what I just said, but different. Put them in separately, not together. So if I put it in the first one, and I'm trying to find what y equals, 4 times -2 minus 1. So that's -8 minus 1, or -9. If I did the second one, 2 times -2 minus 5, and -4 minus 5, which is still -9. Either way. So that means my y value is -9, so my ordered pair is -2, -9. And that would be my answer to this solution. Now, of course, you can still graph these. However, let me say this. You can still graph these when it comes to the practice. There will be a section of the test that is specifically solve by substitution, solve by graphing, which means I need to see that you can solve by substitution and or graphing, depending on the objective. So you could still do that, so graph it to check yourself, but you do need to be able to do this work. Right? Moving on to number 2. Here, we again have an equation that has a y by itself already. So what we're going to do is take this equation and we are going to substitute in the other equation wherever we see a y. And that's really what we did in the first one. We took this equation and substituted it with y, or you could say vice versa. We took this equation and substituted it with y. It was just a little different because they were both y. In number 2, there's only one other y, and it's in the equation. So where that second y is next to 3, I'm going to put 6x in for that. This is the substitution part of this method. So what I'm going to do is rewrite the second equation with the first equation in it. I'm actually going to change the color of it so it stands out a bit. Now, I am just going to solve this for x. So here I would need to multiply 3 and 6x. In this case, I have 2 x's that I can combine. And then divide everything by positive 20. So here I see that my x is -1. Because I know my y equals 6x, I can put -1 in for x to figure out what my y value is. And I can see that this is going to be -1, -6. All right, let's do some more. Number 3 is very similar to number 2, except now this one has a whole equation. Like if we were graphing this, it would have a slope and a y-intercept. I mean, number 2 had a y-intercept, it was just 0. It wasn't listed. But this one still has a y equation by itself. So I'm going to put this equation into the other equation where I see y. So I'm going to rewrite this other equation with my first equation into it. This is me substituting this equation into it. And then I'm going to solve. 3x plus 8x plus 72 equals -5. I can combine my x's and then solve for x. So in this case, I would need to get rid of my 72 by subtracting. So 11x equals -77 and divide. Okay, so now I have that. Now I can put this back into my equation for y. So remember, there's always 2 parts. There's always 2 things you need to substitute. An original equation into another, and a number into an original equation. So y equals -7 plus 9. So y equals, +2. So our equation is -7, +2. If you're looking for, is this going to be one solution, infinitely many, no solution when you solve these last 2 that we just didn't have variables on both sides. That automatically means it's going to have one solution. Okay, number 4. This one now has an x equals, so be careful. It won't just always have y. This now has an x equals, so I'm going to put this in for the x in the other equation instead of y. So when I rewrite this equation, and I almost did it, I'm going to put this in for x now instead of y. And I am now going to solve this for y instead of x. I'm going to multiply these and get 8y plus 14 minus 6y equals 12. I can combine my y's. 8y minus 6y is positive 2y. I can get rid of my 14 by subtracting. And then divide. So here, y equals -1. And then the step is still the same. I am now going to take this -1 and put it into this equation. So x equals 4 times -1 plus 7. So x equals -4 plus 7, or x equals positive 3, sorry. So my ordered pair, now remember we solved for y first, is 3 -1 because it's always x, y. We're going to do 3 more of these, starting with number 5. Now, we no longer have something that's x equals or y equals something. Now we need to choose one of these equations and solve for either x or for y. I'm going to say this. You still have free reign over this, but I'm going to say this because it's going to help. If you see a term that has just x or just y, even if it's negative x or negative y, use that equation, solve for that variable. If you use anything else, it might be a little bit more complex. So for number 5, I'm going to show you what would happen if I used a different variable also. So first things first, I need to solve this equation for y, because this y is what I want by itself. So I'm going to subtract 2x on both sides. Now I have an equation that is just y equals, so I'm going to put this equation into the y value of the other equation. And remember, we solved this for y already, so it needs to be what we solved, not the original in this case. And then I can start to solve this for x. Oops, that should be minus. I can combine my like terms. And start to solve for x. I'm going to add 6 to both sides. And then divide everything by negative 1. Now, you have a couple different options. You can either put this back into the original or into the one you solved. If you put it back into the original, you're going to end up solving a little bit. But if you put it into the one you solved, you just need to find the answer and simplify. So our ordered pair, or our answer here, is 1, negative 4. Really quickly, as a side note, let's say you didn't want to choose that y just because, for whatever reason, whatever. You could have chosen the 2x in that same equation or anything else. Let's say you really wanted to solve for x in that first one instead of y, which is fine. So I'm going to solve for x. I need to get rid of y and divide everything by 2. Oops. Because I divided it by 2. Now, when you go to put this into your other equation, you are now dealing with this fraction. Did it again. So when you do this, sometimes you'll end up with not nice looking fractions that you'll have to do something with. So now we need to combine negative 5/2 and 3y. You could just use Desmos. I'm just going to do this really fast. and then you would still need to solve it. And then in this case, I would need to multiply both by 2. I know I'm like writing sideways, sorry. Oh, I got something completely different. Back over here, when I divided by -1, this should have been +2. And then I should have put in a +2 here, which made this -4, which made this -6. Now they match. Okay. Anyway, all of that to say, you could solve for whatever variable is not by itself. You may just end up with a bit more work. So just keep that in mind. Alright. Oh, and then you would have had to put -6 back into the original equation and you would have got 2. Moving on to the next one. We're going to do 7 and then 9. So for 7, I see that this x is by itself, so I'm going to solve for that x by subtracting the 5y. Now I can take this equation and put it in for the x in the other equation. And I just realized I changed all my colors, I'm sorry. Okay, I can combine my like terms. Here, when I combine my like terms, -15 plus 15 cancels or becomes 0, so I have no y's left, and I end up with this. If you think back to when we were solving and we had something like this, so earlier to my statement of it'll always be one solution, that is clearly not true, sorry. This is going to be no solution because these do not equal. That means if I were to graph these two, they would be parallel lines. Okay, and then for number 9, I see that I have this y by itself. I'm going to solve for that y and put this equation into the original or the other equation that has y. (6x minus 6x plus, plus 54 equals 54. You probably already know where this is going, but let's do it anyway. 6x minus 6x is 0. Those cancel. I no longer have x's. And I'm left with 54 equals 54. Well, that's a true statement, so that means this is going to be infinitely many solutions. So if you end up with no solution or infinitely many solutions, you will not be able to solve for both x and y. At some point, it will stop you because you don't have an x or a y.